to share the screen. So after array, now next we are going to discuss about functions. Okay. See, functions are simply a block of code where suppose to avoid writing repetitive code, right? So suppose you have certain program, say you have a certain logic to implement, in which suppose after executing a certain block B1, you need to write certain logic, say L, and after that there is another block B2, and then you need to write
Sir,
another.
excuse me, sir.
हाँ बोलो.
Are you sharing screen?
Okay, sorry, I forgot that.
Yes, sir. Just no. Okay, sir.
So recording also.
Recording is started. Recording is already there. So now as you can see that the same logic is being written multiple number of times. Okay. Now if the logic consists of some huge amount of lines, obviously that is just a wastage of many lines of codes, right? So a better way is to simply implement certain function. This can be void or anything. What does it mean here to write some keyword here? Whereas we can simply write, say, one block of code B1, then L, then maybe that next block of code B2, and simply invoke L again. So this huge amount of code here that's being replaced by certain, that means this particular logic L is being implemented only once and is being invoked multiple number of times, giving the same behavior. Now the question is, suppose what happens when you invoke a function? Suppose I have certain function, say int main, and here suppose I have another function g. Now void means, the void keyword stands for when a function returns nothing. When a function returns nothing. Now suppose there is certain statement, say statement 1, statement 2, right? And in the main, suppose there is again certain statement st1, there is certain statement st2, then g is being invoked, and so on. What happens here? The execution starts always from main function. Does not matter how many functions you have, what functions you have, execution always starts from main function. So the execution starts in this direction. So first st1 gets executed, then st2, then as soon as it sees the invocation of function g, the control goes to this function g, goes to the first line of this function g. Then the statements of the function g gets executed one after another. Then when the execution of function g completes, it comes back, in fact on the same line, in fact from where it was invoked. So when a function is invoked, control goes to first line of the function. Okay. And secondly, when a function returns, it returns just after the point of invocation. So when G was invoked, the control goes to the first line of the function G. Okay. In this case, the G is called the callee function or invoked function, and the main is the caller function or invoking function. Okay. Now the control goes to this line, the first line of the callee function. When the execution completes for this function G, the control comes back exactly after the point from where it has been invoked, and the execution of the next lines for the caller function begins normally. Okay, it resumes normally. Let's see with an example. Suppose here I am writing printf line 1 of main, then maybe line 2 of main, and then suppose I am invoking a function G. Okay, here we are defining the function G, where I am writing this line 1 of G, line 2 of function G, and let me invoke another function F. Okay. Here it is only these two lines here, say line 1 of F and line 2 of F. And here we are simply, let me write the line 3 of G. Now after invoking G here, suppose I am writing line 3 of main, then I am invoking the F directly, and then line 4 of main. Okay. Now let's execute this. Now let's see what is happening here. The program always starts from main function, does not matter how many functions are there. So here the main function, the first line is line 1 of main gets executed, then line 2 of main, the execution begins in the from the first line towards the last line, so line 2 of main, then function G is invoked, right? As soon as G is invoked, the control comes to the first line of the G. So line 1 of G, line 2 of G. Then it sees the function F invoked. F gets invoked from this line. Okay, I am pointing this out here. G got invoked from this line. Now f gets invoked from this line, so control comes to the f function. So line 1 of f, line 2 of f. Now as soon as line 2 of f done, so we have printed up to this line 2 of f. As soon as line 2 of f has been done, the control comes back, and the control comes back. So when the function invokes, control goes to the first line of the state of the function, and when it comes back immediately after the point of the invocation. So it comes back exactly at this line, but after the invocation. Okay, and so on this line it is only this statement is there, so the next statement gets executed, line 3 of G. So after line 2 of f, line 3 of G gets executed. Now G is done here. So G is done. So it will go back to exactly from where it was invoked. It was invoked from this line. So it comes back exactly at this line when it comes back. Okay. And on the next line, it prints line 3 of main. Then on the next line, now I'm invoking f. So the control comes on this line. Line 1 of f and line 2 of f. After it is done, it comes back at this line as well itself. Right? And after it comes back to this line, it just next executes line 4 of main. So this is the complete output that is happening. So every time some function is being executed, it is going to the first line of the invoked function, and when it is returning, it is coming back to the caller function exactly at that line of invocation. Okay, as for example, main invoked G, G invoked F. When F will return, it will not return to main. G invoked F, so when F will return, it will return back to G. Right? Then G will return back to main when the execution of G will finish, and it will continue in this manner. Is it clear? Is it clear to all of you?
Yes, sir.
Okay. Now, till now, we did not pass any parameters here. But the functions can also contain parameters. That means in general, the structure of a function is the return type, then the function name, then the parameters one by one. Suppose first parameter separated by comma, second parameter, and so on. You can send as numbers of parameters as you wish. Now, when you will invoke this particular function, to invoke this particular function, as you can see here, you directly write the name of that function. So if the name of the function is, say, f1, or yes, suppose f1. So when you will invoke this function, you will invoke f1, then you will pass certain arguments, arg1, arg2, and so on. The number of parameters should match the number of arguments, and the argument are passed to the parameters one to one in sequential order. That means after this line, the first parameter will get the value argument 1, the second parameter will get the value of argument 2, and so on. Okay. Now each parameter, any particular parameter is represent in terms the data type of that particular parameter, then the parameter name. And when you will pass an argument, right, when an argument is passed, the argument typecast itself to the provided parameter type. Let me show with an example. Suppose, again, till now I am not considering any return type. Suppose void f1 that has two parameters, int a, int b, right? And suppose you are doing printf %d, then suppose a space %d /n ab, and then you are suppose invoking a function from main, and here you are invoking suppose f135. What will happen as soon as you invoke this function f135, the control will come back to this line. Now these arguments will match these parameters one by one in sequential order. So a will get 3, b will get 5. First parameter will get the value of the first argument, second parameter will get the value of the second argument, right? So f1 will start in this manner. So eventually on this line 3, 5 will get printed. After printing this, it is done, so it will come back to this line, and so this will be the output. Now if the data type would be something different, then it would typecast itself accordingly. Let me show this with an example. Suppose in F I am writing a character A and int B rather than int A, int B. Let me remove this G now here. And here suppose I am invoking F with say 65 and say 289. Okay, and let me keep this. And suppose I am printing %C, %D. I'm printing A and B. What will happen here is that A will get the value 65, B will get the value 289, but it is a character A. So this integer 65 will typecast itself to the character data type, right? So what will happen is that this variable A will contain the character capital A, because 65 is the ASCII value of capital A. So eventually on this line, what you'll see is line 1 of F is capital A and B gets the value 289, so capital A 289. Okay. So when you pass arguments to a function, the parameters get the arguments one by one in sequential order. Okay. Any query up to this? Next is
Sir,
हाँ बोलो.
Sir, in passing the parameters in the function, why we write int a comma int b? So we can directly write int a comma b.
Int a comma b. Let's check.
Yes, sir.
As you can see, unknown type name b. The fact is, this is not a variable declaration like you do like the as the first statement of a variable int a comma b. Both a and b gets the type int, but it is not like that. For every parameter, you have to provide its corresponding data type. Okay, that's the grammar according to the grammar.
Okay, sir.
Now, in fact, all the programming languages out there, every data type, every parameter needs to have its own data type. As long as that is a static typing programming language like C, Java, or something like that. Static typing means you have to provide the data type of each variable yourself. The variable will take its space in memory according to the data type. Whereas there is another type of programming language that is dynamic typing programming language, where you do not provide the data type of a variable, rather you simply assign some value, and from the value assigned it infers the corresponding data type, like Python, like JavaScript. Okay. But in static typing programming language, when you pass a parameter, you have to provide the data type for each parameters you are passing. Alright, so just excuse me. So next is when your function has some return type. Till now we have seen about void type, right? Now a function can also return certain value. Suppose if I write say int f, suppose int a, int b, and suppose you want to provide return a plus b. Now in int main, and you provide that corresponding you return that corresponding value using the return statement. And int main, you can catch the value into certain variables. Say int c equals say f35. What will happen is that again this f will be invoked. The arguments will go to the parameters 1 to 1. So a will get the value 3 and b will get the value 5, and it will return 8 because it is returned a plus b, right? In fact, you can provide this within a bracket, you can write that without a bracket, you can provide any expression here, anything. If you provide any expression here like what you have done here, it will calculate that expression first, then it will return. So it will return 8. So when it returns, this invocation takes it here and returns takes it back here, right? So C after this line, so this line is equivalent to int C is equal to 8. Okay, so C will get the value 8 after this line. So the returned value can be received in a variable, right? And when a function faces return statement, returns immediately. That means the next statements will not get executed. Let me show this with an example. Suppose here you want to return certain int value, and here suppose you are catching that value in some variable a, and you are returning a plus b. After that you also write a statement, say printf, this is unreachable code. This such type of codes we generally call unreachable code. This code will never be reached. And printf %d a. The fact is what you receive is the sum of 65 and 289, and you will not see this line printed. This is unreachable code. Okay. So when a function returns, it returns immediately without any next statements or so. The fact is this feature of return is also used in void functions as well. If you write some void function, say f, suppose we generally use in some void function, suppose you do a huge amount of complex mathematical calculations here, then you check if this condition is true, return b2. What does it mean is that after b1, okay, if maybe you are doing some calculation here b1, then you want to check that is the calculation is still in the right path, user has provided some wrong input, that this condition should be satisfied. If c1 is true, maybe that is not a valid input, or that is not a valid calculation result, return. Otherwise execute, otherwise continue with b3, continue with b2. Right. So if c1 turns out to be true, this return will be executed and it will return immediately. Right. b2 will not be executed then. But if c1 is false, after b1, if c1 turns out to be false, b2 will be executed. So this return statement is used in void function, but obviously not returning any value. It is just there to return to the caller function immediately. Is it clear?
Yes.
Now, in the function, we generally target two types, two parts of this. One, declaration of the function, and two, the definition of the function. When we write something like this, return function name this and so on, this line, from this line up to this line, from return statement all the way up to this closing bracket, before this opening brace, this part is called declaration part of F1. Whereas this one, starting from this part to this part, this is the definition of F1. Okay, definition cannot be there without declaration, but declaration can be there without definition. A function can only be declared but not defined, but obviously it has to be defined later on. The fact is, there is an important rule that must be kept in mind while writing a program in C, that if a function, say if function invokes the function g, either the definition or declaration of g must be before f. Let me demonstrate this. As for example, the function f is here, right? If I define this function later on, you can see that it will immediately give you an error. Implicit declaration of function. In this case, it's a warning. Okay? Because main has no idea that f is going to appear later. So either its complete definition should be before the main function that I wrote it in original version, or at least its declaration should be there.
Sir,
Ah,
if a function is declared before main and there is no definition for it, what will happen?
okay. In this case, that will compile but will not execute. It will show that the definition of f not found. It will compile. Let me show this. Okay, before let me show that this will compile without any warning on error. So the declaration of f is there. Now let me remove this, and you will see that this will, in fact, if you just compile this will compile. Okay, but when it will try to link this, remember the steps of the compilation. When it will try to link this, it will show me this error, undefined reference to f. Okay, this line shows that it got compiled successfully, but while linking, remember in the linking phase, all the unknown symbols are satisfied, right? So f, that means it will try to search where the definition of f is, and then try to link this corresponding invocation in the assembly language, right, in the generated assembly language. But so while the linking, it will see that in fact there is no definition of this f function, and it will create this error, undefined reference to f. Okay, is it clear?
Clear, sir, clear.
Okay. So, any query regarding what I have discussed about these basics? This is just the basics of function. Now I need to show how to pass an array and pointer to a function, and how to return those such array and pointer from a function. Is this basic concept of function clear to you till now?
Sir, why there is a
Yes,
general
sir.
practice of writing int main and then return 0, like that function will work if we will write void only. So is there any kind of memory difference whether to use int or void?
No, there is no separate memory requirements for here. The fact is it will execute normally as well. But the fact is obviously it cannot write return 0 here. Now, what is the disadvantage of not being able to write return 0? Let me tell you that. Suppose, first of all, what happens when you return 0? I think I have also discussed it previously as well. The return 0, the return from main goes to the OS. Okay, goes to OS, and it also represents end of your program. Okay, end of program. That your program has terminated. Now, if you return 0, if OS receives 0, that means there is a successful termination, and if it receives non-zero, then that is an unsuccessful termination. Now, consider something like this. Suppose you want to create a program where it will calculate, say, just as an example, the age of a person given his or her birth year. Now, suppose I am giving year, and I am also writing that enter year not after current year. So if someone enters something like, say, 2022 or 2023, that should be invalid. Okay, so let me read year here as well. But I have to tell the user that if year is greater than 2021, this should be an invalid input and should not be executed. Is it clear? Whatever I tell till now? So this is an printf invalid input. Else printf age, say I am writing %d, say 2021 minus year. Right. Now let me suppose execute this, and suppose I am giving 19, maybe 2018, right? Now if the user gives 2022, invalid input. Till now everything is correct, but somehow there are two things happening here. Somehow I have to inform the OS that in the case of invalid input, the program did not terminate it correctly. User has given some illegal input. So I have to return something, some non-zero value to the OS, because by default in this case the main function is returning 0 to the operating system. In this case, what is generally done is there is a function called exit in the stdlib.h. that is used. Okay, obviously as it is exiting, there is no point of writing else here, because in the case of invalid input, it will simply print that invalid input and will return and will exit with the error status 1. Otherwise it will give me the output as well. So this is also doing the same thing, and here. So both of them are doing the same thing, right? And this is much more reasonable program, because I have shown you just a simple example. In much more complex example, it may happen that due to some invalid calculations, or maybe due to some invalid input provided by the user, maybe it involves some division and the user has provided 0. In such cases, it is better that you check that and you immediately exit from the program to the OS with some non-zero return value. Now, the fact is that this is all well and valid program, but in the case of int, if you write the int here, there is no need to send this stdlib.h. You can simply use return 1. Okay, and here return 0. And this will do the same thing. I am not saying one way is better than another way. Every programmer has his or her own programming style. You can choose any one. but this is much more common. Okay. Does it answer your question?
Yes.
Any other query regarding this basic, regarding this concept of function of what I discussed till now? Okay. Now, the next thing that I will discuss is dynamic memory management. Till now,
Sir, sir, only 3 minutes left, so start this discussion in next class.
I was thinking about continuing up to 7 today. Okay, so we already have had up to 3:40, right? So when would you like to do the next class? Let me tell you what will be our next discussion. 1 hour. There's this dynamic memory management. And along with dynamic memory management, I'll just have a discussion on array, pointer, and function. And then structure and union. Only these 3 topics I'll discuss.
Sir, you haven't included strings.
Strings can be discussed along with any of them. String is a small topic. In fact, structure and union itself does not take 1 hour. Maybe I can discuss string along with this. Okay.
So,
Generally, string is discussed with array itself, but I'll discuss it in the later. So, tell me. Bolo.
Total how many hours, sir?
so could you
This one-
please continue
Three.
now? Because on Monday we'll have a practical and it won't be possible to attend class on Sunday. I mean, we'll have to study.
In fact, I was not going to take class on Sunday. I'll take the class on Sunday only to E in that scenario, because all the topics that I'm discussing here, that's why I'm discussing all these topics here, so that you do not need to attend the class on Sunday. Okay, so just discuss among yourselves and let me know within 5 minutes whether you would like to continue this class now, or eventually I'll discuss these 3 topics, or you would like to discuss these 3 topics in the next week. Not on Sunday, maybe on any other days at some 5 to 6 class or 6 to 7 class. Let me know.
Sir, D1 group says not now.
Okay, D1 group says not now. And what about okay, rather than this discussion, so what is your proposal in the next week? Can you give me 3 classes?
Sir, 3 classes mean 3 hours or?
Yes, 3 hours, just 3 hours.
Sir, on that Friday, Thursday we have user classes then.
If you agree with that, using the classes on Thursday and Friday, I have no problem. I can leave the class now. That means I can leave the class here at this moment. So that's what I'm discussing. I'm telling you to discuss among yourselves. Just take 5 minutes, discuss over your WhatsApp group or somewhere else, and also take a break of 5 minutes at that time, and let me know. Okay. I have no problem taking in class now. I have no problem taking in class in the next week. Even if you tell me that you can do class on certain days from 6 to 7, or on certain days at any time, because I think all other classes will not be there. At any time, you can tell me, except Thursday 10 to 11. Okay. At any other time, you can also tell me that you would like to do these 3 hours at this particular time. Is it clear whatever he said?
Yes, sir. Clear. We are discussing, sir.
Yeah, sure. Let me take a break of 2 minutes as well. Okay, tell me, uh, will there be any other classes in the next week?
No, sir. Sir, D1 has decided Thursday 3 hour class.
Thursday 3 hour class. Okay,
Yes, sir. We are fine with that.
Thursday 3 hour class. Okay, no problem. From 2 to 5 we'll continue.
Sir, instead of Thursday,
Okay.
3 hour, can we do Thursday and Friday usual time?
But I think Friday is D2's lab, na? D2's lab or D1's lab is there.
Yes, sir. We have a lab on Friday, so Thursday will be okay for us.
Okay, then no problem. Thursday 2 to 5 class will be there. I'll take this class. Okay, and I will finish all these topics. Don't worry.
Okay, sir.
Okay, so
Discussion over, sir.
yeah, sure. Discussion over. Thursday 2 to 5 final. So let me
Okay.
close this topic here today. Anyone have any queries regarding today's concepts of function? Just the last question. Because these were just the basic concepts of function, or any query from this afternoon's class about this array and pointer, the multi-level pointer and array that I discussed. Any of you have any query? Okay, so then we are done here. I'm stopping the sharing and I'm stopping the recording.